Hello students, in the previous lecture we have derived equations of motion. Now today we are going to solve some of the numerical problems that are based on equation of motion. So starting with the first question is a bus accelerates uniformly from 54 km per hour to 72 km per hour in 10 seconds. So the initial velocity, which is denoted by u, is 54 km per hour and the final velocity is 72 km per hour. The initial velocity is denoted by u and the final velocity is denoted by v. Fine. And the time is 10 seconds. So according to the question, time is 10 seconds. Now the question is, calculate acceleration in meter per second square. Now look, the initial and the final velocities are given in kilometer per hour. We need to convert it into meter per second, means SI unit of speed or velocity. Fine. Now how to convert kilometer per hour into meter per second, which is equals to 54 kilometer means 1000 meter and 1 hour is equals to 3600 seconds. So cancelled, we have 5 upon 18, which is equals to 54 into 5 upon 18 means it is equals to 15 meter per second. Means if we multiply the term which is in kilometer per hour with 5 by 18, it will give you the answer in meter per second. So the initial velocity is 15 meter per second. Similarly, for the final velocity, we have 72, multiply it with 5 upon 18, we have 20 meter per second. So the final velocity is 20 meter per second. I am repeating again, whenever you need to convert kilometer per hour into meter per second, multiply it with 5 by 18, because kilometer per hour means 1000 meter upon 3600 seconds, which is equal to 5 upon 18. Fine. Now we have initial and the final velocities in meter per second. Time is already in seconds. Now we have to calculate the acceleration. Now the first part is acceleration. The formula of acceleration is v minus u upon t, means final velocity minus initial velocity upon time t. So the final velocity is 20, initial is 15 upon time is 10 seconds. So which is equals to 5 upon 10 means 1 upon 2, which is equals to 0.5 meter per second square. So meter per second square is the SI unit of acceleration. Clear? Now the second part is calculate the distance covered by the bus in meters. So distance means S. Now look, we have the value of u, we have the value of v, we have the value of a also. Fine. Now we know that S is equals to, using second equation of motion, we have ut plus half at square, where u is the initial velocity, t is time, a is acceleration and s is distance. Fine. Now putting the values, the value of u is 15, time is 10 seconds plus 1 by 2, acceleration we have 0.5 into t is 10 square. Clear? Now solving it, we have 150 plus 1 by 2, 0.5 is also 1 by 2 into 10 into 10. Clear? So we have 5, same 5, it becomes 150, 5 into 5 is 25, 150 plus 25, which is equals to 175 meters. So the acceleration in this question becomes 0.5 meter per second square and the distance traveled is 175 meter. Clear? Now let's move to the second question. The question is a train starting from rest. Rest means initial velocity of the train is 0. Fine. Moves with uniform acceleration of 5 meter per second square, means acceleration of the train is 5 meter per second square. Fine. Find its velocity means we need to find final velocity when it has traveled a distance of 1 kilometer. 1 kilometer means 1000 meter. Fine. Remember one thing, we need to convert all the quantities in SI units. Clear? Now we have initial velocity, we have acceleration, we have the value of distance. We need to calculate final velocity. We have three equations of motion. V is equals to u plus at, S is equals to ut plus half at square, and v square is equals to u square plus 2as. Fine. In these two equations we have distance. Fine. But in the question we don't have time. We don't have time. Fine. So we will use the third equation of motion, in which we have the value of u, we have the value of a, we have the value of s. Fine. So by using the third equation of motion means v square is equals to u square plus 2as. V square is equals to the value of u is 0, 0 square, 2 into acceleration is 5 into distance is 1000. So v square becomes 10 into 1000, which becomes 10,000. Fine. So v square is equals to 10,000 and v becomes under root 10,000. Fine. Under root 10,000 means 100 into 100, or you can say 100 square. And this square root cancels with the square 100 square. Fine. So v becomes 100 meter per second. Fine. So the final velocity of the train is 100 meter per second. Clear? Now the next question is the brakes applied to a train moving at 90 km per hour. Fine. Means the initial velocity of the train is 90 km per hour. Fine. We need to convert it into SI units, means meter per second. So multiply it with 5 by 18. So 18 5s are 90. It becomes 25 meter per second. So the initial velocity is 25 meter per second. Produces a retardation. Retardation means a negative acceleration. So A is 5 meter per second square. Because it is a retardation, means a negative acceleration, we need to apply this negative sign with this. Fine. Now the question is what distance will it cover? Means we need to calculate distance. Fine. Before coming to a stop. Means the final velocity of the train becomes 0, because the question says before coming to a stop. So the final velocity of the train is 0. Fine. Now we have the value of u, we have the value of a, we have the value of v also. We need to calculate s. Similar to the question number 2, we use third equation of motion, means v square is equals to u square plus 2as. Fine. The value of v is 0. The value of u is 25 square plus 2 into the value of a is minus 5 into s. Clear? So it becomes 0 is equals to 25 into 25 is 625 minus 2 into minus 5 is minus 10s. Fine. Now shift this negative sign to this side. We have 10s is equals to 625, or you can say S is equals to 625 upon 10, which is equals to 62.5 meters. So the distance is 62.5 meters. Now let's move to the next question, question number 4. The question is, find the displacement of the body whose velocity time graph is shown below. Here is the velocity time graph. Fine. As we had discussed in the previous lectures, whenever we need to calculate distance or displacement in velocity time graph, we need to calculate area under the graph. Fine. So distance or displacement of the body is equals to area under A, B, C, D. Fine. Now area under A, B, C, D, which is a trapezium, means area of trapezium A, B, C, D. Fine. So the formula of area of trapezium is half into sum of parallel sides into height. Fine. So half, the parallel sides are BC and AD. Fine. Parallel sides are BC and AD. And the height of trapezium is, look, BE or CF. Clear? Now put the values. We have 1 by 2 into the value of BC from B to C, means 2 to 8. So 8 minus 2 becomes 6, plus AD is from A to D, means 0 to 10 is 10, into BE from B to E, means from 0 to 10. Height is from 0 to 10. So it becomes 10. Clear? Now solving this, we have 1 by 2 into 16 into 10, or you can say 8 into 10, which is equals to 80 meters, because the SI unit of displacement is meter. Clear? I am repeating again, whenever we need to calculate displacement in velocity time graph, we have to calculate the area under the graph. So this figure is a trapezium. Fine. Means we need to calculate the area of this trapezium ABCD. The formula of trapezium is half into sum of parallel sides into height. So the parallel sides are AD and BC. Look, these two lines are parallel to each other. Means BC plus AD into height is BE. Now putting the values, B to C means 2 to 8. So it becomes 8 minus 2 is equals to 6. So here is 6. From A to D means 10 to 0 is 10 minus 0 is equals to 10. Clear? Into height is from 0 to 10. Fine. Now cutting this 2 with 16, it becomes 8 into 10, which is equals to 80 meter. Clear? Now let us discuss question number 5. So the question is, the velocity time graph of a body is shown below. We have this velocity time graph. Now we have different parts in this question. Let's solve the first part of this question. So the question is, state the kind of motion represented by OA and AB. O to A and A to B. Fine. As we had discussed earlier, that whenever we obtain a straight line like this in the velocity time graph, it will represent uniform acceleration or the constant acceleration. So OA represents uniform acceleration, means in this case the body changes its velocity equally in equal intervals of time, so we obtain this straight line. Clear? Now AB, look at AB, from A to B, the body does not change its velocity, means the velocity of the body is 20 meter per second only. So we can say the motion is constant velocity or zero acceleration. Clear? I am repeating again. From A to B, the body does not change its velocity, so it has constant velocity or zero acceleration. Clear? Now, the second part is find the velocity of the body after 10 seconds and after 40 seconds. So here is 10 seconds. After 10 seconds, the velocity of the body is 20 meter per second. Fine. So after 10 seconds, the velocity of the body is 20 meter per second. Fine. Now, after 40 seconds, after 40 seconds, the velocity of the body becomes 0. So after 40 seconds, the velocity of the body is 0 meter per second. Clear? Now, third part is, what is the negative acceleration of the body? The negative acceleration means the velocity of the body decreases with time. Now look at this region from B to C. The velocity of the body decreases in this region. So from here we can calculate the negative acceleration. Fine. So third question C part is, the formula of acceleration is V minus U upon T. Now in region B to C, the final velocity of the body is 0. At C, the velocity becomes 0. But the initial velocity means at point B is 20 meter per second. Now from B to C, the time is from 30 to 40, means 40 minus 30 is equals to 10 seconds. Clear? Now, we have the formula A is equals to V minus U upon T. The value of V is 0, the value of U is 20 and the value of T is 10. So it becomes minus 20 upon 10. It will give you minus 2 meter per second square. Because it is a negative acceleration, the answer of acceleration should be in negative. So this negative sign indicates it is negative acceleration or retardation. Clear? Last part. Find the distance travelled between 10th and 30th seconds. So 10th and 30th second. We know that whenever we need to calculate distance in a velocity time graph, we have to calculate area under the graph. From 10 to 30, this is area, means a rectangle, or sorry, means a square from 10 to 30 and 0 to 20. Means distance is area of A, B, E and F. Clear? So the area is equals to length into breadth, means AB into AF. Fine. So AB means from 10 to 30 is equals to 30 minus 10 into the value of AF from 0 to 20, means it is 20. So it becomes 20 into 20, which is equals to 400 meter. So distance is in meter. Clear? I am repeating again. Whenever we need to calculate distance in a velocity time graph, we have to calculate area under the graph. Means area of this A, B, E, F part. Fine, which is a square. Means AB into AF, or you can say side square. Fine. So AB, the value of AB means EF, which is 30 minus 10, which is equals to 20. The value of AF is 20 again. So 20 into 20 is 400 meter. Meter is the SI unit of distance. Clear? So these are some important numericals that are based on equations of motion. Clear? Thank you.